Hello class, this is a continuation on conditional probability and independent events. The formal definition or calculation of conditional probability is the probability of A given B is the probability of the intersection of A and B divided by the probability of B. And this is for non-independent events. Now recall, if two events, A and B, are independent, then we found that the probability of their intersection is the probability of A times the probability of B. Considering this, the conditional probability of two events is, well, we're going to eventually get to this point here, but I'm going to demonstrate to you how. So if you have the probability of A intersect B, now, if A and B are independent, then we can substitute this for this. This is only if they are independent divided by the probability of B. So I'm just copying this exact same line here with a substitution of that expression here. This is only true for independent events. Now, with just some algebra, the probability of B is multiplying and then being divided. So we can cross off those, leaving us with just the probability of A. So this is only true for independent events. Along with other principles and rules of probability, we can determine whether events are or are not independent to one another. Here's a summary of all the different probability principles and rules, although I've actually left out a few here. These are just mainly the ones with set notation. So basic probability, complementary probability, the sum rule for probability. This one here is going to be important in this exercise. The intersection of probabilities. This is only for independent events. For other cases, counts only common outcomes in both events. Refer back to the first video to understand what we mean about this. Or the probability of the intersection will be provided. And the two that we've just learned are these ones here. Probability of A intersect B divided by the probability of B. That's the conditional probability. And the conditional probability for independent events is the probability of A given B is just the probability of A. Now let's use these different principles, mainly this one here, along with this one, to determine whether or not these events are independent or dependent. Let's consider this. Now to solve this, we need to remember what we are looking for. What we're looking for is if A and B are independent, the probability of A intersect B is just the probability of A times the probability of B. That's 0.3 times 0.6. That's 0.18. So this is what we are looking for. Probability of A intersect B to be equal to 0.18. We are looking for this in what we've been given. So let's figure out and work with what now we've been given. So this is our target. So probability of A given B is equal to the probability of A intersects B over the probability of B. Substituting all the values that we have, the probability of A given B is 0.3. In this particular example, because remember these are just the conditions we've been given, so in these conditions We don't know what this is yet, so let's leave it as probability of A intersect B over the probability of B is actually 0.6. So 0.6. Using some algebra, I'm going to multiply this to this side. So 0.3 times 0.6, that's 0.18, is equal to the intersection of these two. Notice how this is equal to what we are looking for. So in this case, A and B are independent. So they are indeed independent in this particular example. Let's do another one, just so we get our heads around this. You can probably expect that this won't be independent, but let's just get on with it so you can see how this goes about. Now, we should always begin with what we are looking for. We are looking for the probability of A intersect B. Now, if A and B were independent, it would be 0.3 times 0.4. I believe that would be 0.12. So we are looking for this condition here, 0.12. That's what we are hoping to find. Now let's actually work with what we have. The probability of A given B is probability of A intersects B over probability of B. A given B is 0.5. We don't yet know what A intersect B is, but we do know that the probability of B is 0.4. Multiplying 0.4 to this side, we get 0.2 equals the probability of A intersect B. Notice how in this particular example, by working with what we've been given, this does not equal. Therefore, in this condition here, A and B are not independent, so we can say that A and B are dependent. And there we have it. So I hope you get the idea of what we are working with. You can pause the video and give these two a go yourselves. There's a slight change in this one. It's the A union B is given that. And as I've stated before, we will definitely be using this one here. So go ahead, hint, hint, look at that. So I hope you pause the video and give this a go yourself. At this point, you can kind of end the video because I'm just going to be solving these as we go. So here we go. So the ideal situation that we are looking for is the probability of A intersect B is 0.2, this one here, A, times 0.15. This one I don't know the solution to. So if A and B were independent, we would have this expression showing. So let's give this a go. So this is if they are independent. Let's calculate what we've been given. Using the sum, so A union B, I'll just write it again. You can scroll up or look through your book to find this. The probability of A plus the probability of B minus the probability of A intersect B. Substituting what we have, A union B is 0.32 is equal to probability of A is 0.2 plus the probability of B, 0.15. And in this example, we don't yet know what the intersection is. Now remember, we're hoping that it will be 0.03. Let's solve for this. That's 0.35 minus probability of A intersect B. Treating this as if we would algebra. Subtracting this, we get, what do we get? 0.32 minus 0.35. That's negative 0.03 equals minus probability of A intersect B. Multiplying both sides by -1, we get 0.03 is equal to the probability of A intersect B. Now take a look. That's exactly what we are looking for. It's matching. Therefore, A and B are independent. One more example here. Once again, we are looking for the target of, so if A and B were independent, then the probability of A intersect B is equal to 0.5 times 0.35. What's that? Okay, so we're looking for 0.175. So that's our target to aim for. Again, let's utilize what we have using the sum of probability rules. I'm going to substitute straight away. So 0.7 is equal to probability of A plus the probability of B minus the probability of A intersect B. Once again, we can't use this one here because this is the ideal situation. This is our target goal, not one we can use. But let's take a look. Let's solve for this. 0.85 minus probability of A intersect B, minusing from both sides, 0.85, so 0.7 minus 0.85, that's negative 0.15 equals negative probability of A intersect B. As we've seen before, just multiply by -1. That leaves us with this expression. So in this particular situation, these conditions have given us this result. This does not match what we are looking for. Therefore, A and B are dependent. So I hope that gave you an insight into using the formulas to determine whether two events are or aren't independent. Hope to see you in the next video. Best of luck.